Welcome to the rising demand for cooling in data centers, Bitcoin mines, and AI servers. In this digital age, data is everything. From streaming our favorite shows to powering artificial intelligence, massive amounts of information are being processed every second. But behind the scenes, there's a hidden challenge: cooling these massive heat-producing technologies. Take Bitcoin mining, for example. These machines work non-stop, solving complex equations to verify transactions. This process generates intense heat, and without proper cooling, hardware performance suffers, or worse, systems shut down entirely. Then there's AI servers. Training artificial intelligence models demands immense computing power. The more advanced the AI, the hotter these machines get. Keeping them cool isn't just about efficiency, it's about preventing costly downtime. So, how do we cool these high-tech powerhouses? Traditional air cooling is still common, but modern facilities are turning to liquid cooling, immersion cooling, and even waste heat recovery systems to improve efficiency. With global temperatures rising and energy costs surging, the industry is under pressure to develop greener, more efficient cooling solutions. The future of digital infrastructure depends on it. As technology evolves, so does the need for smarter cooling. The question is, how will we keep up, and who will work on it? Hello, everyone. Thank you for joining us again on Did You Know, the ESCO HVAC show. It's pretty interesting when we start thinking about where HVAC and refrigeration has a role in technology. Our world is just escalating at a speed that is almost hard to fathom. And we play a very crucial role in that. So today we're going to spend some time diving into maybe some areas that you haven't thought about for your training program, or if you're a contractor, opportunities that you haven't recognized yet that is going to be crucial for our industry. So today we're spending some time with Ken Duncan from Belimo. How are you doing, sir?
I'm doing really well. Good to see you, Cliff.
I'm grateful that you're joining us. You're going to be doing a class at the National HVACR Education Conference, diving deeper into this topic right here. I actually have a QR for those that are going to be joining us at the conference to make sure to check out that class and learn a little bit more about intelligent control valves and the way our industry is being affected by technology, and especially when we get into artificial intelligence that is operating and managing and looking at preventative opportunities for these technologies. So let us know where you're joining in from. We love to know how large this community is growing. I'm here just outside of Indianapolis, Indiana, in Brownsburg. Ken, where are you joining us from today?
So I live just north of Seattle in beautiful Mount Vernon, Washington, the tulip capital of the United States, I guess.
Oh, wow.
Yeah,
Yeah, my wife would absolutely love coming out there for a while.
it's a beautiful area.
You know, in my time in the field, I've done a variety of different pieces of technologies. I kind of made a name for myself by working on things that most people would turn down. Because I was fortunate enough to have a good instructor early on in my career that taught me refrigeration, and consequently the ability to work on anything refrigeration, because it was all kind of part of that fundamental refrigeration cycle.
Right.
Hey, Paul, I'm glad that you're here. Paul, this one's really going to be interesting. I think you're going to enjoy this because I know you've been spending a lot of time with us, learning about technologies and things that we can implement into the classroom. And this is going to be a hot topic in a very short period of time in our classrooms. Thank you, Mr. Tebby, for joining us today. So in my time, I actually got to work on a couple of different data projects. One of them was just, hey, Osvaldo, thank you for joining us from Belize again. Glad that you're here. You'll like this, Osvaldo. This is an interesting technology that is affecting our industry worldwide. So this is going to be right up your alley. So my first introduction into a server scenario was a local energy co-op, and they had a rooms, about a 15 by 20 room, that was all servers, that was just maintaining their digital records, all their clientele records, and monitoring, how the function of their grid, basically. And so when we did a heat load calculation on this little 15 by 20 room, it ended up being like a 4-ton air conditioner. So it was a ducted system. And then, that was my first introduction into, wait a minute, I've got a little room with a lot of cooling capacity. And that was really intriguing. And so I've seen a couple others along the way, but what we're witnessing in the industry now is just something completely different. So, Ken, tell us a little bit about your introduction into the industry, because I absolutely love this story, and it goes back to the importance of technologies in the vocational training programs.
Right. Yeah. So yesterday we were talking about a little bit about my background, and I told you that when I graduated from high school, I went to a community college south of Seattle, and I was in a program that I decided wasn't my exact spot where I wanted to be. So I went to the career center and took uh, a test that basically told me what my top five interests were. Hi,
Mm-hmm.
Randy. And one of those was HVAC, and I had no idea what HVAC even was back then. Fortunately, there was a community college in North Seattle that had an HVAC tech program, a 2-year Associate of Arts program. So signed up for that. Spent my 2 years at North Seattle Community College. Was fortunate that I got nominated for an award called the Washington Award for Vocational Excellence.
Mm-hmm.
And what that allowed me to do is that allowed me to go and continue my education and get my 4-year degree. And my tuition was paid for by uh, the state of Washington under the Vocational Excellence Program.
Very cool.
And then I was a resident assistant at college to pay my room and board, because I wouldn't have been able to afford to go to the 4-year college if I wouldn't have had the scholarship and had the ability to be an RA.
You bet.
Um, and ever since then, I've been in the industry. I came out of college working on pneumatic systems, receiver controllers and designing pneumatics, and then uh, joined into the DDC, the direct digital control system era, and joined Belimo about 5 years ago, and recently became part of the data center group. And that's my focus is on the vertical market of data centers, because the data center market, like you've said, is exploding right now, and the technology that we use to cool the data centers has changed immensely, and we are being forced to move into liquid cooling of the data centers. Air-cooled systems just don't provide enough cooling anymore, and so we'll talk a little bit more about that during the show this afternoon too.
Sure, absolutely. When we talk about air to water, I personally believe it's the future of our entire industry, especially as we start moving into our not just low but ultra low GWP refrigerants. When we get to things that have characteristics like high flammability or high toxicity, it's going to be required to have those refrigerants outside of the structure. And so a air to water or water to water, a way of keeping the refrigerant circuit outside and using higher capacity flow of water, glycol, whatever that media ends up being, is very effective, especially when we're talking about systems like this. So can you give us just kind of an overview of how we're functioning inside of these data systems?
Yeah, so your graphic is one of the better ones. Um, so traditional data centers that were built probably 15 years ago were really an extension of our HVAC, our typical HVAC system,
Yeah.
where you had an air handler with an economizer on it. When it was cool outside, you would utilize your economizer cooling to cool the data center. Instead of cooling people, we're cooling equipment or
Yeah.
the servers. Um, and that was when the rack density was much lower than what we have today. And so we refer to the amount of heat that the racks put out in the term called rack density. And typically it's a kW rating of the racks. And so we're moving to in the other side of the air cooled systems. When they used economizer cooling, there was also a lot of evaporative cooling
Oh
that was
yeah.
used.
Sure.
Well, water is
Yeah,
becoming
moisture.
more expensive, and it's important for us to use water efficiently.
Yeah.
And the amount of evaporation that was used in those evaporative cooling, that water became fairly expensive. And in fact, Microsoft, one of their global initiatives uh, is to reduce water use.
Yeah.
And if you go to LinkedIn or look at any information on Microsoft, um, their new data centers are zero water use facilities. So it's a closed loop system. Once we fill the hydronic system up with water, we don't have any evaporation. So they're very efficient on the water side. Um, and you'll see that it's becoming more and more important that we use our resources efficiently when we're trying to cool these huge data centers.
Yeah, absolutely. Next Tuesday, I'm actually going to be down at the Danfoss Turbocore facility down in Florida. I got invited to come down and do a behind the scenes tour of not just the processes of the equipment that they manufacture, but their new energy efficient systems they've incorporated into their own buildings for manufacturing. Exactly like this. We're reducing our energy consumptions as much as we possibly can. And so we're starting to have the technology to do that. So when you talked about the density of systems, I love these two slides that you brought over. We're going to look at this one first to kind of get a representation of how our systems are actually cooling within these, modular data components.
Right. So this diagram here really shows the GPU server, the server racks out in the middle of the data center with the hydronic piping in the floor. And you can see the branch lines running from the mains back to the servers. And then over at the left side of the graphic, uh, those silver boxes with the black tops, those are what we call our CDUs. Those are cooling distribution units.
Okay.
And they're basically a heat exchanger in a box. So that is the intertie between the central plant, so your primary chill water system, chillers, cooling towers, and the what we call the rack cooling system. So
Sure.
very similar to a primary secondary type system, but they are completely isolated from one another through the CDU. Um, and like you mentioned earlier, that allows the chillers with the refrigerants to be located outside. And then also we're seeing more and more of air to water chillers, so heat recovery chillers, and they're usually located either outdoors or up on the roof of the data center.
Yeah, they actually have one heat recovery system in their new construction that I'll be checking out next week. So really
Good.
looking forward to seeing that. So
Yep.
when we start talking about this density, so that is that is a more of an animated version of the way the systems are laid out. A lot of people don't realize how much equipment is actually going into these systems and the amount of heat that is being generated off from these.
Right.
So, when we as a HVAC industry look at, our opportunity to work on these centers, we used to be very much involved with that air to air exchange, working on ducted systems. But as that is moving away, it really is going to be relying on our industry again, but with a new technology. So how are we removing heat from racks such as this one?
Yeah. Is there a way for me to bring my barbecue graphic up for everybody to
Yes,
see? Just
absolutely.
share it.
Yeah, you can just share screen and then
Perfect.
let me bring us back to a blank scene.
And we'll see if that comes up.
Yeah, absolutely.
So yeah, and this was not a graphic that I built. Somebody else in the industry brought this graphic up, and it was a great visual
Can you just go
help
to the
here to realize
screen?
how much heat these racks actually generate.
Sure.
So if you took 15 Weber barbecues and put them inside a server rack and turned every one of those barbecues up to high fire, that's how much heat we need to remove out of a server rack,
Out of a single rack.
out of a single rack. And those racks are what we call a high density rack. And typically it's around 120 kW worth of power, which is majority turned into heat.
Hmm.
And we need to remove that. And being an HVAC guy, I like to refer to this in tons of cooling, because 120 kW, Yeah, I can kind of understand what that is. But when you say I have 34 or 35 tons of cooling in that small rack, I can't imagine a rooftop unit and the ductwork that would be necessary to supply 34 tons of cooling to that small space.
No, that's incredible to think about.
And
We don't have that kind of a capacity.
right, and that's why the need is that's why we're switching to liquid cooling is that we physically can't supply enough air to that small area to remove the heat faster than it's being generated. And 3 or 4 years ago, those racks would only put out 30 kW. And if you look at a 5-ton rooftop unit or an 8-ton rooftop unit, that's totally doable with air, or
Right.
it's possible. But once you get up to those 34 tons, there's just no way that we can push that type of air. You know, that would be close to 14 or 15,000 CFM of supply air
Wow.
pushed into a space that's I don't know, let's say 6 by 10 or 8 by 8. It's not a very large space. It's
I
just
was
not.
getting ready to ask how big
Yeah,
one of these typical servers, these new high density servers are.
yeah. And some of the, if I guess probably the best comparison I have is if you bought a big built-in refrigerator for your house,
Mhm.
a commercial size, that's probably a similar size to one of the racks. So they're not that large. And that's what's necessitating for us to cool that and take the heat away with a liquid rather than trying to do air cooling.
Okay.
And the servers are getting more and more dense. I mean, it's kind of like the Apple phone where every 5 years or something the power of the device doubles. Well, we're doubling the heat output of these servers every year.
In the
Um,
same space, same physical
and
space.
same physical space, right? Um, and so that's going to be the next frontier here is when we can't supply enough cooling with water, what's the next logical step?
Hmm.
And that's already being, I guess, researched in the industry with immersion cooling, where we
Yeah.
physically take the server and the entire server is submerged in a fluid um, to try to get rid of the heat quicker. So all kinds of new technologies out there. It's exciting, but it's also terrifying how
Yeah.
fast things are progressing.
Well, we're thinking about that, and I'm thinking about the single server rack that I worked on, and it was probably in that same dimension. It just sat in the middle of this 15 by 20 room. It had probably 6 to 8 feet all the way around it for walking space, except for the electrical supply to it. And we're talking 20, maybe even 25 years ago, and that was a 4-ton unit on a single system. And now we're talking 34 tons on probably the same physical footprint of the one that I'd worked on back then. That's just almost astronomical to think about. So,
Right.
you shared one photo that I think is really interesting to me to show how we remove heat from some of these servers. Can you explain what we're actually doing inside for heat sinks to be able to remove heat from these electronics?
Yep. So we directly feed a fluid, typically a water-based fluid, into the heat exchanger, which is physically attached to the GPU, the graphical processing unit, and we take the heat away from the GPU rather than letting the GPU heat up the air in the data center and then trying to remove the hot air.
Sure.
So we try to remove the heat at the source. Um, Believe it or not, there's a lot of technology in just how do you cool a GPU, um, because GPUs have hot spots and cold spots. They're not a uniform
Mhm.
surface, and so that is the job of the heat exchanger manufacturer that is attached to the GPU is to design that heat exchanger so that you effectively remove heat from the chip evenly and keep the chip cool. Um, and that's what you're seeing here. You're seeing a lot of the tubing. The other part that I guess would be interesting for people in industry is to understand that the water quality has to be pristine in
Mm,
these systems, because if
sure.
you see the small copper tubing and the heat exchangers, um, typically they filter these systems down to 50 or 20 microns, so that we don't have any blockage within any of the passages within the heat exchangers on the GPUs. So the water quality is another very important consideration when they're
Yeah.
building these plants.
I can only fathom, especially for the construction of the copper itself and for the heat exchangers. I mean, it would be
Right.
devastating to have a failure of a joint because of acidity or erosion, corrosion
Hmm.
inside of these high performing, very expensive electrical components. So
Yeah.
that's intriguing. I've not seen it laid out this way. That's when you shared this photo, it started making sense because I can see the blocks and then I can see our round tubing. So are we primarily supplying our water through the round tubing and then removing heat on the block areas?
Yep. And everybody has a different style of heat exchanger. There are many of them out there in the industry. I mean, everybody hears about NVIDIA. They have a GB200 GPU chip that everybody uses. That's kind of the industry standard right now. But the equipment that cools that GPU can be different. And
Okay.
then the CDU units, the cooling distribution units, that's a whole nother portion of the industry. Um, who's building those CDUs? What are the requirements of those CDUs? Uh, the industry, it's a fairly small vertical market, the data center market, but there are so many different industries that are involved in just serving data centers.
Yeah.
I mean, we're looking at the mechanical side of it, but look at the electrical side of the data centers providing all the power, and how do you distribute that much power to a data center, the substations, the utility providers, instantaneous loads as the servers turn on and off. The electrical side of the
Okay.
business, I think, is way more complicated than the cooling side of it, but it's still challenging. And boy, it's going to be a great market for people in the industry to make careers out of this. Um,
One of the struggles, like from the very smallest of applications of refrigeration cycles mixed in with the plumbing side, is we're starting to see in residential, like commercial, a lot of, we call it heat pump water heaters, but they're still just, they only flow one way, so it's really just a refrigerated circuit water heater. But we call them heat pump water heaters, and so you have the HVAC refrigeration industry going, it's connected to water, so that's really not our market. And you have the plumbers going, but it's connected to a refrigeration circuit, so it's really not my market either. And then stuck in the middle is the educators going, but wait, we got to teach both of these because they're going to be functioning in the same component going forward. And so this is another example of how these air to water solutions are very much going to be the heart of our industry going forward.
right.
Yeah, Tom. I'm curious if anyone in the audience has ever worked on these. There's a lot of R&D that goes into this, and you're right. I think about like the gaming PCs. I've seen a lot of personal gaming PCs that are now starting to use fluid cooling systems, and it's very much that same principle. But now we're going to be using our chillers and our refrigeration circuits to be able to manage this heat load. And it's interesting when you mention how much of that energy we're using on the startup of these systems. And I'm sure across the globe it's based on those demands, those times when those computers are being used the most, and the capacity has to be variable on these. So on some of these projects, how large, had some videos in the beginning, how large are some of these projects that you're now working with?
Well, they're immense. I want to ask or answer Tom's question I see there
Yeah.
too about the flow path. So I know that ASHRAE is a partner with you, Cliff, in the
Yeah.
education here, and I'm an ASHRAE member and have been since I was in college.
Great. Thank you.
And back at the AHR conference that we had in Orlando a couple of weeks ago, there's an ASHRAE Technical Committee 9.9, and it's about um, direct chip cooling for data centers. And
Mm,
part of the research that subgroup is doing is relates to the erosion of the heat exchanger when the water flow, the velocity is too high through
yeah.
the heat
Imagine.
exchangers on the GPUs.
Sure.
And so that's one thing. I mean, that you're right. I mean, we need to worry about how fast we're flowing the water through the heat exchangers and these very small, I'll call them pipes
Mhm.
within the computers, to make sure that we don't erode erode any of the piping, or have a failure where we have pressures that are too high for the fittings.
Okay.
And we don't want water running through the middle of these $1 million servers.
Yeah.
So
Wow.
That's a whole nother issue. Um, Now, the size of these facilities is kind of mind-boggling. And if you get on LinkedIn and looked on link and search through LinkedIn, you'll see that there are companies that are specializing in building modular chiller plants.
Hmm.
Um, because the data center industry is progressing so quickly, they don't have time to put chiller plants together out in the field like we normally do on a normal
Sure.
construction site. So what they're doing is they're building modular chiller plants that can be shipped on a standard flatbed truck and then assembled in modules. And I know Microsoft published somewhere on LinkedIn that they had a 21 chiller skid that they were putting in somewhere in the US to provide cooling for one of their data centers. And it was a group of 21 chillers with pumps, everything that goes along with that, the
Yeah.
electrical, the controls, and then they're going to assemble that at the job site, make the cross connections between the containers, um, and have a central plant up and running in a very little amount of time.
Yeah.
So that's another industry that's tied into the data center market is just the chillers, because we don't do air side economizer cooling anymore. We have to do
Exactly.
everything with chilled water. So
Yeah.
the demand for heat pumps and chillers is growing exponentially too.
Yeah, Jay, I'm glad that you brought that in for us so we have an idea, of the expansion that we are seeing in this. And so, yeah, if you have any photos on your phone that you can throw in there in the chat, I would absolutely love to see them, or email them to me sometime. I'd love to have an idea of, of some of the systems that you're encountering in the field. Because the reason why I wanted to bring this topic, onto the show was traditionally I knew Belimo from the whole hydronic side of our industry and from our air control as well. I hadn't really thought about it for the primary sources for controlling and managing and moving water that is now part of our conditioning, right? It's part of that conditioning side of our industry. I mean, you're using variable capacity controls and variable speed pumps, and we're actually managing the entire system and engineering from the ground up. And so now we have our technician side that is going to be confronting this, going, wait a minute, uh, this looks kind of familiar, but from a whole different perspective. And yeah, Tom, it's where we see the amount of heat generated off from these is just astronomical. When I was at AHR last a couple weeks ago as well, I spent some time with Dan Foss and Johnson Controls looking at their strategies for how are we going to manage some of this heat removal in the future. And one of the things that they're trying to focus on is moving these large data centers that we have typically put out in the middle of nowhere, bringing them into the city where they're a little bit closer to the electrical transmission supply, but also been thinking from a larger scale, what other facilities need heat? Because remember, as I'm removing 34,000 BTUs of heat, that is 34,000 BTUs of heat that I can put someplace that actually wants it. Remember, we're all in the business of moving heat. That's really all we do. And so now we're relooking at our infrastructure going, okay, we are going to have this amount of data for the growth of our needs for technology and communication.
Yeah.
And so we're going to have to manage these. And so we are going to be spending a lot of time with systems that are moving heat from these high heat generating structures into others. And that's going to be our job. That falls on us.
Yeah, and that's the next phase for this industry, is to do heat recovery, and
Yes.
rather than just rejecting this heat to the outdoors. McKinstry actually has a project in Seattle where they have a data center downtown, and they're taking that waste heat and distributing it to nearby buildings
Yeah.
to use as heat, rather than
Right.
rejecting it. But you're right, a lot of the data centers are remotely located out in the middle of the country where there isn't a real demand for that waste heat. But we're seeing more and more data centers that are installed, smaller data centers that are installed maybe on the top floor of the building, and then they're using that waste heat to heat the
Correct.
building or adjacent buildings. So yeah, we're starting to see more and more of that, and I think you'll continue to see that as energy costs go up and up. We're going to try, I mean, you'll see the owners trying to find a way to recover some of that lost
Yeah.
energy.
I think about that myself. If I'm building a multifamily structure and I know that there's going to be, heating costs, why not utilize another portion leased
Right.
out to someone that's using a data center that I can actually grab that heat and reintroduce it? It's a lot of electrical supply, but that's also, that's cheap heat that we can
Right.
place in places that we need it.
So,
All
Cliff,
right.
I threw a
Yeah.
picture in there of that modular chiller plant. I just pulled this off of LinkedIn this morning. So, if you
Awesome.
want to just get a visual of what the skid looks like, that is one of the skids, and you can see it's on a seagoing, a platform of a seagoing container. Um, and there's just rows and rows of these being built in their warehouse. And then they can functionally test these, package them up, and ship them to the job site, but they're completely self-contained. You'll see that there are all the electrical, the VFDs, the pumps, the control valves. There's actually a unit heater in this picture, so to keep them, to keep the chiller room above freezing. So they are truly self-contained units that they can just build in a warehouse. Nice dry conditions, and every one of those seagoing containers is built identically so that they have the benefit of using the same components, speeding up the fabrication time. If you're out in the field repairing anything, it's going to be identical between all the
Exactly.
skids. So a lot of advantages to it.
Yeah, I think about programs that are looking for, universal type of curriculum. Boy, this is one. Kendrick, thanks for joining us today. This is the type of curriculum, if we could start introducing this style of chiller, because we have a lot of schools that already teach chillers, we have a lot of UA facilities teaching chillers. Well, now if we look at our classroom and go, well, if I could bring in a single modular chiller assembly that I know is going to be used across the country and across the world, now I have a technology that I can train a technician on that is going to be universally accepted wherever they go.
Right.
Hmm.
There are a lot of companies doing that. Like I said, I just pulled this one off of LinkedIn this morning. This is one that I kind of ran into a week or so ago on LinkedIn while I was looking around. And um, again, with data centers, time is money. So anything that can be done to streamline the building of the plant is going to be looked upon favorably by the owner. And so chiller plants, the central plants, take a lot of time and a lot of effort. And so I think this was a great idea to try to modularize this and have a drop and go type plug and play type central plant.
Yeah, I completely agree. For those of you that missed the intro to the show, I think I'm actually going to play it back through again right now so that you'll have a visual of how large some of these data centers are. Because we're going to also be talking about some of these artificial intelligence centers as well, and how AI is being introduced into our industry and into a lot of these controls. And so hopefully this will give you another perspective on how large some of these facilities are getting.
Welcome to the rising demand for cooling in data centers, Bitcoin mines, and AI servers. In this digital age, data is everything. From streaming our favorite shows to powering artificial intelligence, massive amounts of information are being processed every second. But behind the scenes, there's a hidden challenge: cooling these massive heat-producing technologies. Take Bitcoin mining, for example. These machines work non-stop, solving complex equations to verify transactions. This process generates intense heat, and without proper cooling, hardware performance suffers, or worse, systems shut down entirely. Then there's AI servers. Training artificial intelligence models demands immense computing power. The more advanced the AI, the hotter these machines get. Keeping them cool isn't just about efficiency, it's about preventing costly downtime. So, how do we cool these high-tech powerhouses? Traditional air cooling is still common, but modern facilities are turning to liquid cooling, immersion cooling, and even waste heat recovery systems to improve efficiency. With global temperatures rising and energy costs surging, the industry is under pressure to develop greener, more efficient cooling solutions. The future of digital infrastructure depends on it. As technology evolves, so does the need for smarter cooling. The question is, how will we keep up, and who will work on it?
It's kind of scary to be thinking about how significant this is. Um, yeah, Osvaldo, that's a good question. So when we start looking at engineering and load calculations, one of the points that Ken brought up earlier is when we're actually looking at the heat loads of the equipment themselves. So I know for the server rack that I did the load calculation on for, it was a matter of looking at the kW of the each individual component and then looking at how much heat was in the structure. So it's still doing what we normally do. We're doing a load calculation, but now we're adding electronics in because we've always added electronics and lighting into load calculations. Now we're just doing it on a mass calculation.
Right. And also, when you're doing that load calculation, this leads into a little bit about I guess we'll touch on the smart valve
Yes,
technology. Is
please.
right now, if the racks require 120 kW of cooling or 34 tons, 2 years from now, they may want to swap that server out for a different server that has a higher heat density. And so if you use a smart control valve that can be programmed for different maximum flow rates, then if the server ever needs more cooling, you can just go back and program the existing valve. See you, Gary. Thanks for joining us.
For joining us today.
Um, you can always just go into the smart control valve and change the maximum flow rate and allow more water or fluid to flow through the server and cool it.
Sure.
And that's a huge benefit for an owner that might install, oh, let's just say 5,000 control valves in one of their buildings. If they would have used a traditional ball valve or a globe valve or a pressure
Mm,
dependent valve, if they needed to increase the flow rate, they would have to go back and take those valves out of
you bet.
service and put new valves in. So if you utilize a smart valve that's programmable, that's pressure independent, you can change the maximum flow rate and you can change the heat density or the ability for the control valve to remove the heat from the server. And so
Hmm.
that's the beauty of what we have in the industry is thank goodness we have some intelligent devices all the way down to the control valve level that are able to do this. Um, so this is happening now because of the technology. The other side of this is thermal storage. You're starting to see more and more of thermal storage as these servers come online and go offline. The demand for chilled water is instantaneous in some cases. And so you're seeing more and more of thermal storage out there so that we can charge a tank and let the chiller plant pull the tank temperature down. And then when you have a group of servers that come online, we basically have a battery of chilled water that we can run through the server to cool it. Um,
Wow.
so it's an exciting time because
Mhm.
we're using the same applications that we've used in the HVAC industry, but we're applying it to almost an industrial process now.
Yes.
Um, but that process is very finicky, and you have to be careful that you remove the heat fast enough so you don't damage anything. Um, and with HVAC, if someone's uncomfortable in their room and their room heats up to 75 or 76, it's no big deal. If you overheat a server, it may be $1 million chip that you damage. Um, so similar industries, completely different results if it's not done correctly. So
You'd mentioned a little bit too about how AI is being introduced into even some of this management and control. How do you
right.
see AI being a component of our industry going forward?
Well, so down in Las Vegas during the show, I'm going to talk about this, and it's already being deployed. I've been involved in a project in Seattle where artificial intelligence was deployed in a building to verify the energy use of the building and make sure that it was compliant with our state law. And after running that analysis on the building, the AI system picked up some anomalies that the contractor went back and looked into, and sure enough, they found some problems in this building that have probably been present for 10 or 15 years, but they've never been noticed because it's such a large facility. AI was able to find it within a week. Um, and I think we're seeing more and more of that. You and I talked about Kenny Seaton down at Dominguez Hills in
Yeah.
California. And Kenny is one of those guys. He's the facility manager at Dominguez Hills, and he deploys AI on his cooling tower system. So they have a Johnson control system, and they mated that with an AI program, and it continuously adjusts his cooling tower sequence to keep his chiller system running at optimum efficiency. And in fact, there's a graphic that I'll show down in Las Vegas where the chiller plant is running at 0.24 kW per ton with all of the AI that he's deployed on campus. And that's an amazing efficiency out of a central plant. And if you ask Kenny how he does it, he's like, I don't know. AI just does it for me.
Isn't
It
that
makes
crazy?
solutions, and it's continually monitoring my system. So I think AI is going to complement people within the HVAC industry. There really aren't enough of us
Mm-mm.
out there to handle the workload, and AI is going to save us from the monotonous task of pulling up trend logs and trying to analyze trend logs and find faults within buildings. And there are a lot of pseudo AI systems that are already out there that have been in the industry for years, and I think that they're just going to get better and more intuitive, and I think they're going to be very helpful to us um, as an industry and as a society too.
Yeah,
So
no, I agree with that, especially in these automated controls and these larger control systems. Does anyone have any questions? So we've still got other diagrams that we can look at. We can look at some of the controls themselves. There's a lot of things that we can pick Ken's brain on this, because I'm sure many of you are starting to look at this going, yeah, that is us. And we are going to have to prepare for this. And we are going to start doing some training and preparing for technicians. And when we look at what's happening with our industry in every aspect, yes, we have a shortage of technicians in every sector, but we are starting to see other industries looking at ours going, wow, that's pretty interesting. I've been in controls and in software my whole career, and I have a place in HVAC. Or I have been in hydronics my whole life, and now I have the opportunity to be in the cooling side of hydronics. And so there's a lot of interest in our industry in highlighting where this technology is going, and the opportunities that we have in our classrooms and as contractors is just phenomenal. So I really appreciate any of your questions or input that you have.
I think the other fun fact I'll throw out there while they're
Mhm.
asked, see if we get any questions. So most people, when you do a search, you jump on Google and you type in your question, and the Google spawns a result or something, an answer to you. But how often do you use your cell phone or Alexa and you do a voice command to find out information?
Yeah.
So what they've found is if you did two similar inquiries, one typing the question in and one using a voice command, the amount of electricity to process that command, if you do it via voice, it's 10 times the electrical use of typing the answer in, because AI has to analyze your voice, pick up any dialect or anything in your voice, figure out what you're asking. If you type it in, it's in text, and it's much easier for a system to analyze it in a written form as in a verbal form. So if that's one reason why AI is so explosive right now, is everybody is using their cell phone to ask, Siri or Alexa a question, and that takes more processing power and more electricity to process those questions. So kind of an
That is.
interesting fact there, that it's 10 times the amount of electricity to process a voice command.
Yeah, and we think about, the electronics that we are starting to produce. The voice command is now becoming part of all of our vehicles. It is on every smartphone. It is in most homes in some form or another. I didn't even think. I mean, I actually control my lights in here. All my studio lights are controlled by my Google Home sitting on the desk, and that I
Right,
could turn on from my phone through an app, but I tend to use that vocal command. And
right.
so the need for technicians in this sector is not going to slow down. And it actually, when I look at where we're going to need technicians the most, this is going to be one that will exponentially grow as our society continues to grow.
Right.
Wow, that's a lot of great stuff. Must not be too many questions out there. I think everyone's starting to think, okay, well, this is very interesting. Hadn't thought about this. Um, okay, so Jay, this is a great one. This is a perfect one for us to bring in here. So, what is the best way to start training techs for the future and in all AI cooling trends? Because yeah, this is coming. And how do you introduce that, especially into the classrooms? Any recommendations, Ken?
Boy, oh boy. Well, a lot of it goes back to basics. I
Yeah.
mean, we're still dealing with, uh, physics. We're still dealing with how to size a control valve, understand what pressure drop is, understanding what temperature drop is. So a lot of the basics there. Um, so I think that's the biggest thing. We do a lot of training at Belimo, and I know even on the AI side, we do a lot of training with the direct customers, our uh, the big people that I can't talk about.
Yeah.
So even they are still learning how traditional control valves and smart control valves are being deployed in their data centers and make sure that they understand how they work. Um, with smart control valves, they have the ability to think on their own and do some processes that are pretty advanced. And then
Mm.
it's completely different than a normal control valve. Normal control valve just goes open and closed. Well, a smart control valve may determine that it doesn't need to open all the way. And we get phone calls from somebody who say, "Hey, we've sent the control valve a full command signal. Why isn't the valve full open?" Well, it doesn't need to open up all the way to provide the cooling that is required. So sometimes there's a little bit of that disconnect where, yeah, we do need to provide more training so that you understand why a smart valve is doing something that you're not expecting, because it's not what we've traditionally seen in the HVAC field, and sometimes that's confusing. So the best way to do it is to show up in Las Vegas for the conference in a couple of weeks, um, and then I think there's lots of education that's going to be out there, in industry right now. We're flying. I love this analogy. We're flying the data center businesses. We're an airplane flying through the air, and we're strapping different engines and landing gear and stuff on the plane as it flies. We're building this airplane as it flies. We don't have time to engineer a new 747 and get all of the engineering right before we take off. So we're very much a very fluid industry. Things are changing rapidly, and that's what makes it exciting
Mhm.
too. So, if people are out there want to join uh, the data center industry, I'll tell you, it's a market that's going to be growing there, and there's so many niche markets to it too. So,
Yeah, I can imagine, and because there's all sorts of specialty, data, just like we were talking about with a computer. We
mhm,
have a lot, servers that are just dedicated for that computing alone. And
right,
for schools, I highly recommend working with your IT departments. If you're a vocational program that has IT departments, it's a good time to start integrating some of these fundamental commands and fundamental networking into your programs. I've got programs right here. Matter of fact, I seen a while ago. Where is he at? Garrett. Garrett's at an Ivy Tech here in Indiana. I know one of our Ivy Techs up in northern Indiana. They have a solar program right next to their HVAC program, so that they actually work hand in hand, talking about these technologies and how they're starting to work together and starting to bring new controls and automations into the industry that are already coming from other industries. So it is a good time to start looking at other programs within your own schools and networks to start introducing some of these technologies and reaching out to Belimo and learning about what type of classes they have. Yeah, Tom, this is exactly right. So I wanted to introduce this because when Ken and I first started talking about this, Kim was going to be doing a class, and I was talking to him about his class, and I was like, wait a minute. I had no idea that the growth was this exponential in our industry. And it needs to be talked about. People need to understand what's happening in these data centers to realize that this is absolutely us. So I encourage all of you to start thinking about those field trips into a local data center, especially as educators. If we make a call, hey, I'm a local educator, I'm trying to prepare technicians for working on this technology. Is there any way we can get a glimpse of how these systems operate? There's going to be a lot of opportunities out there, I'm sure.
Right. Yep. The only thing is, that typically, if you go on a tour of a data center like this, Men in Black had their neuralizer pen, so at the end you had to look.
Remove everything you just learned.
Yeah, every data center has a neuralizer pen at the exit door, so when you leave, they flash it so you can't remember anything. So it's very top secret. That's a whole nother side of the business, is that ability for those data centers to be standalone, so they're not susceptible to any hacking or ransomware or things like that. So
Sure.
yeah, it's a neat industry, and yeah, if you need to do training, I think there will be more and more resources out there. You can reach out to Belimo if you want something specific. But at the National Education Conference, I'm going to be going into detail on what smart valves do, and some of their capabilities. It's pretty exciting. And the other part about this too is I'm going to do a little bit of myth busting during that class on price, because everybody still thinks that intelligent control valves are going to break your budget, and that's not the case anymore. The price point has come down on intelligent valves. They're a commodity now, and we've seen the growth of use of these valves, even in the HVAC world. Once the electrical cost gets above a certain threshold, it makes total sense to go to an intelligent control valve that has the ability to tune itself and adapt to different operations of the central plant and operations of the building. So a lot of features there.
Do you have any photos? Excuse me. Do you have any photos of those smart valves you might be able to share to our audience while they're here, in case they're interested in come take a look at this class to dive a little bit deeper into it?
Yeah, let me show you. This is a pretty good graphic here. Get this to come up.
Sure.
So this is a screenshot of a PowerPoint that I'm going to do down at the educational conference. This is a live web-based graphic from one of our energy valves. So if you log into the energy valve, this is a live graphic that you would see, and the depiction of the valve is pretty realistic there. It has a flow meter and a control valve on it. But all this information is available in real time so that you can analyze the performance of the valve. And this is independent of a control system. So you don't need a control system tied into the valve. This is all contained within the valve itself. So that's just a little teaser of some of the things I'm going to go over at the class. The other thing that I guess to be aware of is a lot of the companies, the control companies out in the industry, are already including an AI chip in their application specific controllers.
Really?
So there's one vendor that actually have 3 processors inside of their application specific controllers. So like a heat pump controller, a fan coil controller, small controllers. They have a dedicated AI chip that they're embedding in their controller now for future use. So people are understanding that, hey, we don't quite know what AI is doing for us right now, but we're going to set up for the future. And that's one of the huge benefits of, an energy valve or a smart control valve. We don't quite know what's around the corner. But if you have the equipment deployed out in your building, then you're going to be set up for any future changes that may come your way.
Hey, Gary, thanks for sharing that. We really appreciate that, because that's really what we're hoping to do is, help people realize that it's here, it's not coming. We need to start preparing for this now. When I was at HR, I had one of our normal participants that joins us here on the show, caught me in the aisle and he says, you sure been beating this drum on heat pumps. Is there something else we can talk about? I'm like, oh yeah, we got plenty of things we can talk about. Heat pumps are very important, but to understand, that our industry is growing very significantly, very drastically, and we have our own part to do education, and we have an awareness that is going to probably change your perspective on what we serve to the industry. A lot of people go, well, I wish we made more money in the industry. Well, you make more money by becoming more valuable. And working on this type of equipment and technology will make you valuable. Guaranteed.
Well, yep. That is very true.
All right, Ken. Well, I sure appreciate you joining us today. I'm going to throw in a little bit of AI-generated music for us to leave. I hope it's decent. There we go. So here in Restream, they actually create all of their own AI music. Let's go for some more cinematic. All right. And everyone, thank you so much for joining us today. We're grateful that you're here. We'll be at EGIA next week, so we're back out on the road again. So, I don't know, we may be broadcasting live from there. I don't have anything planned, but there's a very good possibility. And if you're looking for new topics for us to cover, I encourage you to grab this QR. I'll leave it out there as well. A little feedback form. Give us some topics that you want to learn more about, and we'll make sure to get them here for you. All right, Ken, thank you, sir. We appreciate your time here.
Thanks. Thank you, everybody. Good to see you, Cliff. Take care.
Thank you as well. Everyone, have a great week, and we'll see you next time on Did You Know? The ESCO HVAC